Good morning, everyone. We're at the top of the hour here, so we're going to start getting things kicked off, and we're going to get some stragglers still joining in, but I will go ahead and start sharing my screen here. Actually, sorry, I need to present in Teams. Perfect. Hopefully everybody will be able to see my screen in just a moment here. Awesome. Welcome to our next webinar, everyone. My name is Kevin Grover. If you've seen the last number of sessions we've had, I lead the customer success team here at Looq. And this webinar this week is going to be just talking about the different data formats and data types and the ways we can actually disseminate the information within our platform. So I'm going to be doing a short demo on this, and we'll leave some time for questions at the end. So for those of you who aren't familiar with Looq, we'll kind of do just a little basic update of the platform and who we are as a company. So we are a startup based out of San Diego. We've been around for several years here now, and we have a handheld photogrammetric reality capture platform. So we have three sections for our processing stack. We've got the QCam itself, which is our handheld device itself. It's a survey grade GPS device on it. It's got some onboard AI processing and a multi-camera sensor. So it has four camera sensors on it with PPK, and we're able to capture incredibly high detailed ground-based data using our handheld device. The processing stack is called QAI. This is basically our automated processing platform that does all of the PPK processing, the imagery processing, and then projects it all into the different formats that we're going to be talking about today. Our web application is called QApp, and this is the web platform that's simple, easy to use, collaboration platform for basically sharing, viewing, and processing the data. So as far as how our platform works, we'll just kind of do a really brief overview. We do have the ability to do PPK corrections using kind of an auto service that we've got, but for our kind of higher precision, we support the using a local base option. So in this case, you'd set up a local base on a known point, log a RINEX file, and then you'd go on and do the capture with the handheld platform. You walk around with the platform. You can walk with a quick walking pattern. This allows you to collect things like curb lines, parking lots, power lines, poles, other asset inventory. We have a really seamless way of doing the data capture. As far as working in the office, basically the data is processed or basically zipped up on the device, and it's automatically uploaded to our web application. We have a few ways to upload it. Allows you to add it to a site and do all of the different GNSS processing steps and automatically deliver this in a web application. So all of the formats are exportable, and that's really what the webinar is going to be about this week. So I'm going to dive right into it, and I'm going to do a little bit of a live demo here to start with. We're going to kind of show you just the web viewer itself and how to access the data. Then I'll be going through all the individual data formats that we do support. So I'm going to just take a moment. I'm going to stop sharing, and I'm just going to share my screen here instead. And hopefully everybody's going to be able to see this. So I am now in our web application, so just in one of the sample data sets that I've got. So we break it into a 2D view and a 3D view. The 2D view, when you navigate into it, you can basically have different data formats here that you can toggle on and off. You can see different data sets. So you can actually merge different data from different sites. It is at the site level, so everything is at a projected coordinate system, which is why we can see our data. You can get the background mapping in Google Earth, and you can see the data available for your project. If we want to just focus on one data set, you'll see I've got the background mapping turned on, but the navigation around it is pretty basic. We can see some different ways to do some screenshots on the left-hand side, some different features for doing measurements, whether it's point measurements or area or line work measurements, you can navigate through here. The other side is the red dots. These are the actual images that were collected. So we have a way to toggle this on and off. All of these are exportable as well. But when we click one of these, it'll basically bring up the panoramic image. It brings up another screen here, so I'm not going to show it at the moment, but what it'll do is allow you to see the panoramic image that's captured at ground level. Then we have the ability, we also generate a high resolution orthophoto. This is one of the ones that we will talk about in a bit more detail on the slides as they come up. But this is where you can navigate around and see basically a high resolution ground-based image. It will be even a little bit higher resolution that you download. It's a geotiff that gets exported, but you can see this and navigate this around in the 2D view. So we break it into 2D views that are very easy to use kind of in a web environment. If we look at the same data set in 3D, this is where we look at the data set that is the point cloud. It'll take a second to load here. We just pushed an update this morning, so I'm hoping that that's not breaking things. Of course, that's the challenge of the live demo. If it does, then what I'm going to do is actually jump over to a different viewer, which I think I'm going to have to. Sorry about that. Give me 1 second. I'm going to stop sharing that. And I am going to just share a different screen. Perfect. So I've got this 3D data set that's already loaded here as well. So when you bounce the 3D side, bounce the 3D side, now we'll be able to see the point cloud. We do load all of this in a 3D environment here as well. So similar to the 2D view, you've got some different ways to navigate on the left-hand pane. I won't go through everything other than we've got some different visualization settings to be able to see. Point outline's a nice one to turn on. So as you start loading more data, it's going to keep loading the point cloud in a tiled format. So you sit there and wait for more data to load, and it's going to load more resolution as you sit here longer as it just loads a level of detail. Different ways to adjust the brightness and the gamma. So if you want to start adding and basically making your RGB data popping a little bit more, you can start customizing the parameters, but we have some pretty decent default parameters right out of the box. Different tools for clipping and cross sections, ways to measure within browser. Again, if we want to just do simple distance measurements, you can click from point to point and basically get some measurements in browser. Images can also be shown here as well. You can see where all the image locations were taken to the 3D view. And then the QSaver tools is where we could basically get into our line to control in our virtual survey. So we've done some past webinars on these, so I'm not going to tackle these ones today. I'm just focusing on the visualization of the data product. So the one other feature is the classification. So this is one that, again, we will show this from the LAZ file that's exported as well. Is the classifications is kind of the magic around a lot of the workflow that we do within our application is we do make the data a bit more intelligent as you're doing the collection. So as part of the processing, we do automatically classify the data. So you see that we've got things like lamp standards. So if I start turning off the street lights on the data set, you'll see that it's color coded and it comes off. Classification is never perfect, but we actually do a pretty good job of, if we wanted to even isolate our ground classes, I can go through and basically just isolate all the data from my ground. And I can see now in a 3D view that I can see just the point data that I've now isolated from my ground data. I can turn this back onto RGB to see this in the 3D view here. And now you have a much cleaner data set that I can actually just work with of just my ground data. So that's one of the benefits that's automated through our processing stack, that this is done with every data set. It's included as part of the processing. I'm going to bounce back to the Teams, to the PowerPoint here to start looking at some of the different slides. I'm going to present in Teams again and present. Sorry for bouncing back and forth here. And I'm going to jump ahead to the downloads. So within the web application is where you can download all of these files locally to your desktop or network location. So the first one I was showing you was the RGB data set. So this file itself, it's an LAZ file format that we use for the export. So LAZ is a very standard point cloud format. It's based on the LAS file format, but LAZ is the zipped version of it. So it's about a 10% file size from the LAS, but it's an open format that pretty much every software for point clouds into Esri software, into QGIS, it can basically read natively. We do export this in with a few different variables, and I will break this up into what we export. So we do include the RGB data, and it is projected in the site coordinate system. So we do support a number of different EPSG coordinate systems. So if you want to work at a UTM or a state plane system, all of these data formats are exported in the coordinate system of your choice. For a typical 15-minute capture, just for kind of an idea for like a streetscape like this, it ends up being a very small file format. So if you're working, again, if you've worked with point clouds in the past and dealt with terrestrial scan data or mobile scan data, there's significantly larger file formats. But for us, a 15-minute capture, you can typically do about 1.5 to 2 acres of data capture, and that ends up only being about a 1.5 gigabyte LAZ file. So very usable in a lot of the desktop software. The one feature here is going to be the automatic moving object feature. So you see that there's actually vehicles that are removed from the data. We actually have a way to filter this as part of our processing. So I'll jump over to the next slide here to talk about that a little bit more. What we look at doing is actually segmenting the imagery, which is really one of the powerful things that we do from the image processing piece. So we do automatically segment here. So this example here on the right-hand side is we're segmenting sky, poles, roads, walkways. This is what we use for the classification. Because we have so many images with the 4-camera system and the way that we do the overlapping capture, we're able to do this quite easily to do this for noise removal, privacy filtering, moving object filtering, which is why the data sets that we have actually end up looking so clean. So that one data set I showed you, initially, that was actually an active roadway with cars driving by, people walking on the sidewalks, but all of that data is actually filtered as part of the processing. So it looks like a very nice clean data set as part of it. With this filtering that we do and the different segmentation, this leads us to the classified version of it. So what I showed you in Viewer is where we actually do the classification, which is essentially layering the data set inside the LAZ file. So these are all exported as part of the LAZ. So if you're working in software that can actually handle classification of data, this is one of the powerful things that we support as well. So we do follow the ASPRS classification standards. So the lower numbers, kind of up to class 11, is basically all of these standard classification formats that ASPRS supports. After that, they end up becoming kind of more defined or user-defined. That's where we basically get into these different custom classes that we support. So if you export this and bring this into a QGIS, which I'll show you the even as well, you can view these and navigate and same thing, layer them on and off in your third-party software. So the benefit of what we do with the classification, like I showed you the ground surface, that leads us into one of the other formats, is we do generate this high resolution orthophoto. So for anybody that's worked with orthophotos from drones or other aerial capture in the past, these are very standard formats. The benefit of what we do is that we actually do the ground classification. We take all the images and we project them on the ground as well. And then we're able to generate a very accurate orthophoto at ground level. So as we're walking, we're able to have this very high resolution geotiff that we support for export into third-party applications as well. So with this, you can kind of see the zooming in part where that X is. We export out a few different resolutions, so you're able to make out a very high level of detail from the data. We do export 3 different resolution options currently. The full resolution is an uncompressed geotiff. So anybody that wants to work with the highest resolution format available, it ends up being about a 6mm point spacing. So it's a very dense orthophoto that you can bring in. That's why we also export out into the 1 centimeter and a 3 centimeter JPEG compressed geotiff. This just allows you to maybe work with the data in some third-party applications that can't natively handle the compressed or the uncompressed format is better. But again, these are all standard geotiff formats. You can use them and convert them in any third-party product like Esri, the spatial analyst product, or even in QGIS Global Mapper. They basically read into all of those natively, and you can work with them on your own. But really nice data set that can work in a 2D planimetric sense for doing very simple extraction within your, say, a CAD application. The panoramic images themselves, so this is actually kind of one of the projected, it's one of the flattened images. Because we've got 4 cameras, we don't do a complete 360. There are 2 side-facing cameras, a front-facing camera, and an upward-facing camera. And that pretty much provides with a 270-degree field of view. They are not fisheye cameras, so that's the one benefit of our platform as well, is we do actually have an actual standard, fixed focal length camera on all of these. So when we project it out, that's how we're able to generate this panoramic image. We do export all of these now as well. They're all exportable just as a JPEG. So every individual image is exportable as a JPEG. We do provide a CSV file currently. The CSV file has the projected location for each of the images. And then what you'll also notice within here too is that we do the people and vehicle blurring. And this is again part of the processing. So this person is basically blurred for 2 reasons. They're blurred for privacy and they're blurred for a moving object. If they're static in the scene, they'll remain, but they'll just be, their faces will be blurred out. But if they're moving through the site, they'll be filtered entirely from the data. Same thing with moving cars on the road. The one thing that we have coming soon that I know this is asked for from a number of folks is we are going to be exporting the full pose information. So currently we only export the location of the images, but we will be exporting the orientation of the images here soon. And we're also going to be adding in the raw image export as well. So this is where for things like Gaussian splatting, maybe you want to bring it into the Esri application for the oriented objects or oriented imagery feature. These are all things that we're going to be supporting very soon as well. So some other features we're adding in for the typical data formats that we've got already. The next one we have is similar to the CSV that's exported. We do also have a lot, another format is just a track file. This basically does also show the image locations, but it's as a GeoJSON format. So for some folks that want to bring it into, say, like an Esri web environment or to be able to see and manage all of your data in a different platform, we do export this from the panoramic image locations as a GeoJSON. The difference with this format over the CSV is it's a bit more spatially relevant. It does handle the lat long and ellipsoidal height is what we export out of it. So typically this is where if you want to bring it into a GIS web application, you can use the data there. The last format we've got at the moment is also our thinned point cloud. So we do, like in the first example, we have about that one data set I showed you was about a 1.5 gigabyte point cloud. But for some of our power customers or people that don't need the high resolution, we do also export a thinned version of it. So it's about 10% of the raw file size. So I'll press the button here. Hopefully you can see the transition between the two. This is the thinned point cloud. You see it got a little bit sparser on the ground, but the density in the areas that matter, we've kept the resolution in. So if I bounce back to it, hopefully I can bounce. Oh, sorry, my animations are, PowerPoint animations here. Okay, I can't get it back anyways, but what you can see is the difference between the two. So it will be about 10% of the resolution. So instead of a 1.5 gig, it'll be a 150 megabyte export. It is still an LAZ file format. It's still colorized and classified as well. But if you're working in a product like PLS CAD, that's when you can basically bring it in and get the same similar resolution to get the data on power poles and power overhead power lines that you don't really need a lot of the data at the ground level. So just a nice, simpler data format to work with. You saw my last slide for this slide. Thanks for joining. But what I'm going to do is I'm also going to stop sharing here and I'm going to bounce just into QGIS and we'll just kind of do a really quick demo of bringing the data into a desktop application and seeing what the different data formats are. So I will share QGIS here and I'm just going to create a blank project. And you'll see what we also do support is the different coordinate systems within the file. So I do have the different files that are downloaded. So if I go into the outputs file for my image, if I drag and drop my ortho image into the file here, you'll see that it's automatically updated the coordinate system. So I'm reading in the coordinate system here for 2956, which is the UTM coordinate system for my project. So we do reproject, or the QGIS does read that and can reproject things in the fly. So we support that within here. So as I start zooming in is where you can start seeing the detail. So this is a little target that I have. It's about a 3 to 4 inch stencil that I use for painting on the ground. So we're able to make out some really, really nice level of detail. You can see I'm based in Edmonton, Alberta, Canada. So of course you can even read the markings on the manholes. So we are looking at even different ways of exporting this. But the nice thing about this data format is if people are doing just simple 2D exports or extraction, it's very easy to work with a 2D image if you're just looking for basic 2D extraction. So maybe you are just extracting paint lines, or in the case of you had a lot of people doing like underground locates, they can actually read like the markings from the locates on the ground level. Because this is also spatially relevant, you can extract data to your blue in the face off of the ortho photo here as well. You can also bring in the point cloud. So if I drag and drop even the LAZ file directly into here, it'll take a second to load it. Oh, so this is the, this is the thinned, sorry, the one point cloud. You can see it's actually imported the point cloud into here. I'll turn my ortho image off. So now I've actually got my point cloud in this viewer. If I go in and I'm going to go view and a new 3D map view, this will allow me now, Oh, and I'm not sure if you're going to be able to see this or if I have to actually, sorry, I've got a giant monitor and I need to just share a little bit differently here. I'm going to share my ultra wide screen share. So hopefully you can see this here now. What this does is it brings up the 3D view. I can actually just go, if I remember how to do this here, is I'm going to zoom extents from my point cloud. Now I can actually see my data set in a 3D environment. So within QGIS, our data is very manageable, even in a free open source GIS application. So this way you can navigate and look around in your 3D view. Everything in here is spatially relevant as well, but it's going to load the data as you navigate around. And this is also where, if we wanted to change the style of it, I can now go into my properties and change the classification. And now I can actually view it by classification within the third party as well. So doing this in 3D, they do a terrible way of visualizing this, but all these different colors and everything can be changed. But you get the idea that all of these come through just as you saw these in the web browser as well. Then the last one I've got is the geojson. If you want to see the track that you walked, you can basically drag and drop your geojson file into here, and this will convert the file. And now you can see the data sets. If I turn the ortho back on, you can see the walking path that you were done. I could take this a step further and also link these to the images that were in here if I wanted to see all my imagery in this view. But just for simplicity, I didn't want to bring the images because it's a larger download. But you get the idea of you can work with all of these products in the 3D space. They're all spatially relevant as well. So you can import them to any product if you're choosing, and they'll be available for you there. So I will bounce back to my slide deck, even though I do have just a wrap-up slide. We got a few more updates we'll kind of share on what we're doing kind of for next steps. I will turn this over to Teresa in a moment. Sorry, I'm just going to be presenting a team. Sorry for bouncing back and forth, but Teams is lovely with sharing multiple screens here. And of course, it's going to take me to the end here, but I will jump into our announcement slide. So Teresa, I don't know if you want to hop off mute for a second here.
Quick, in case there are any questions, I just wanted to remind everybody that, first off, hope anyone who's taking time off over the next couple of weeks gets an enjoyable time with family and friends and lots of rest. And we hope to see you back on January 6th for our focus on high accuracy with Looq. So we're really excited about that session and hope that you can join us. And in the chat, I just added the link directly to that session. As a reminder, each session requires individual registration, so that's the session you want to sign up for next. And you can always go to the webpage, and I'll add the webpage link here next, and sign up for other ones as well. You can sign up in advance. So hope you have great time off if you're taking some time off, and we'll see you on January 6th. And I'm handing you back to Kevin in case there are questions.
Perfect. And the only other thing is, yeah, the Looq user conference, we've also got that scheduled into May. So that's another exciting thing. We're looking at doing our first conference there too. So lots of great things kind of coming up on our side. But yeah, no, that's it for the presentation here. We're trying to keep these just short and sweet for the data formats. But if anybody has any questions, feel free to add them into the chat or the Q&A. Or honestly, if you're brave enough, come off mute. I think everyone's been unmuted here now, and you can raise your hand to just ask a question. If nobody's brave enough to answer, then we can end the call. So I'll give one last request. If anybody's got any questions, we can add it in. Oh, okay, we got two brave hands. Perfect. We'll start with the first one. Srinath. Oh, you're still muted. Oh, Teresa, would you be able to unmute folks?
I'm going to work on that right now.
Perfect. I do see a chat that came through. Working on images. Can we get the images geotagged? Yes, so that is, the images do get exported right now as a JPEG. We do only export the CSV file at the moment, which does have the geotags in it. As I mentioned on the one slide, We are going to be updating the export format on the imagery. So what we're going to be adding in here very shortly is the full pose information. So this will include all the orientation of the panoramic imagery, and we'll also be supporting the raw image export with orientation data as well. So if anybody needs that extra information, we're going to be exporting all of that very shortly. But right now you can get the imagery with the image locations as a CSV. It's not embedded directly in the file at the moment.
Yeah, can you hear me, Kevin?
I can, yeah.
Yeah. Kevin, like what all the data formats can be accepted for this processing, like PPK processing, RTK, for like better accuracy point?
For sure. Yeah, no, we'll be talking about that one in the next webinar, but I can go over that briefly. So as far as the PPK workflow, we do support a Rhinex file format. So it can be really of any of the Rhinex formats. It really doesn't matter. So if you're going with Trimble equipment or MLIT or anything, you can all export directly to a Rhinex file. All we basically need is the OBS file. So it is just basically the raw observation file. Typically it comes as a nav file, an ephemeris file, that kind of thing as well. They all just get zipped up onto the upload piece. And then as part of the processing, you can upload your own Rhinex for the processing. And then you can enter in the coordinate information of that base point, or if it's from one of the vendors from like SmartNet or the Trimble network that basically embeds the coordinate information in the header, we can read from the file header. So we support a bunch of different ways for that.
And Kevin, what is the point ppm for this last files?
Sorry, for the point per. Sorry, I missed the question about for the last files.
Like for a last file, what is the point ppm like for 1 meter square? So what is the density of
points per meter? It is very dense. I don't know the actual number because it does vary based on the condition, but it's hundreds of points per meter. It is a very dense data product. So based on what you saw in some of the screenshots, like you're able to make out, like even our control workflow, we're able to make out small magnetic nails. So like even on like the size of like an object that's 3 centimeters in size, we have probably 30 points on the size of a nail. So it's a very dense data product for sure.
Yeah, sure. And how much like area wise or how much volume like this thing we can do at a time?
Yeah, so this is where, so right now I'm just showing about the approximate 15-minute capture. We are just bumping up our, the max capture time at the moment. We're bumping up to about a 30-minute capture in a single scan. A 15-minute capture can typically do about an acre to actually about an acre and a half of data collection with really good overlap. If you, of course, it's going to depend on the site. If there's a lot of dense features that you need to collect, then of course you'll be able to do a smaller area. But in a 30-minute capture, you're easily going to be able to do between 2 to 3 acres of capture in a 30-minute time. So that's just walking basically back and forth as far as the collection piece. And we're going to be bumping that kind of more in the future.
Yep, sure. Thank you. Because like we have larger areas where it is about like around like 10 kilometers linear or 5 kilometers or like in that way. So
For
when
sure.
we have used it, we found like for 15 minutes. So that's where like want to check like what is the exact timeline.
Yeah,
And,
so on our side, we put in about a 30-minute cap for it now. Mostly it's just a processing side. But if you have larger scans, you basically just add them together. So you can do individual captures. They're all going to be integrated with PPK and ground control, and then they'll all be fitting together afterwards. So we did have a past webinar on a survey workflow that did include doing larger captures. So in the links that were chatted through there, we do have the webinar series that was recorded. So you can feel free and go back and even rewatch past ones. The one coming up in January is going to be on higher accuracy, so we'll be touching on that a little bit more as well. So
I'll just jump in here, Kevin, and remind everyone.
We're at time here.
We'll be sending an email out.
Perfect.
Kevin, one last question. Kevin, one last question. Sorry.
Sure.
So, like, my question was like, will it be able to do interior? Because like as it works on GNSS receiver for host file for data tagging. So will it be work under the roof for interior designs and other things? Because
At
like
this
we
time,
have
yeah.
a scope for it.
Sorry, yeah, now we will have another one talking about different capture techniques and for it as well. So currently we do mostly support outdoor capture only. You can do some indoor. It's not one that's optimized within our workflow yet, but we'll be looking at doing more in the future. But I'm happy to connect after to talk more about that as well. So since this one was just more about the different data formats, but we're going to be supporting more of that moving forward.
Good. Thank you, Kevin. Thank you.
You're welcome. Thank you. I think there was one other question that came through about we will digitize the automation curbs using this. Absolutely. You know, you're able to. We do have a tool within our product to do basic extraction that just does point and line work extraction, but it's not automated. It allows you to pick points just in 3D. But all of these tools can basically, you could read it into Topodot, you can bring into any other third-party point cloud application, and you'd be able to run whatever automation on it. The only challenge with some of the automation is some software does rely on intensity data, which is only available on LiDAR. Because we're photogrammetry, we will only export the RGB data. So it does depend on the application that you can be bringing it into. Perfect. Well, we're at our half-hour time here. So if there's nothing else that people have for questions, then we can end out. Oh, actually, sorry, there's one question from Thomas
There's
here.
one in the Q&A. Yeah, I was just about to tell.
Do you offer your web viewer to share data sites not captured with Looq? Not currently. No, we do. Basically, our platform is built for our Looq data at the moment. So any of the data that's collected with Looq is what we share and host here. Maybe down the road, I'm not making any promises, but as it stands right now, it's just data from Looq that we host within our application. And the one thing on that, it is unlimited sharing, unlimited users. So there's a lot of benefits for using our platform and the benefits of just using Looq in general. Awesome. If anybody does have any questions, feel free to reach out to our team after the call here. So thanks very much. And this will be posted up on our webinar page, and look forward to the next webinar in the new year. So have a happy holidays, everyone, and we'll touch base soon. Thanks so much.